Let's run through some quick examples using what we learned about in the vectors video. So the first example, we have two vectors, A and B. They're written in unit vector notation. And then we're going to define two more. So C is going to be A plus B, and D would be A minus B. And what you need to do is find the magnitude and the direction of both C and D. So go ahead and pause and do that. Okay, so first I'm going to do C. So C is going to be A plus B. So what I want to do is I want to find the components of this. So C is going to be, A is 2, since we're adding, it's just going to be, we just add up the components. So it's going to be 2 plus 3, I hat, and then 6 minus 2, j hat. So we get C in vector notation is going to be 5 I hat plus 4 j hat. But what I want is the magnitude. So the magnitude of C is going to be the square root of cx squared plus cy squared. So C is going to be 5 squared, square root of 5 squared plus 4 squared. So that's going to be, need to calculate it real quick. That's going to be about 6.403. And then to get the direction, the theta is going to be arctan of cy over cx. So theta would be inverse tangent of cy, which is 4 over 5. Let me write that. Inverse tangent of 4 divided by 5. So we get 38.66 degrees. Okay, so that's C. Now we can do D. So the idea is we just carry out the arithmetic and then we apply our vector component stuff. Okay, so D is going to be A minus B. And so since I have a minus, remember that that's just A plus negative B. So we want to get the negative of this. So this implies that the opposite of B is going to be negative 3 I hat. Remember, we just changed the signs, plus 2 j hat. So D is going to be 2 minus 3 I hat plus 6 plus 2 j hat. So D is negative 1 I hat plus 8 j hat. So the magnitude is going to be the root of negative 1 squared plus 8 squared. So that gives me 1 plus 8 squared, 8.06. 8.06. And then theta is going to be arctan of the y component, 8 over negative 1. So theta is going to be 8 divided by 1. So we get negative 82.875. So let's think about what that means. That means we're measuring it this way. So my vector needs to be like this. And that's not holding because we have a negative 1, so it should be coming backwards and then up. So this is not, it's not in this direction. Instead, it's over on the other side. It's over in the second quadrant. Still negative. So negative 1 and then 8. Okay, let's try another example. Okay, in the second example, we're looking at force vectors. And so there's two forces applied to this thing. given by this. So this is 120 newtons at 60 degrees, and the other one is 80 newtons at 75 degrees. And what we want to know is what's the total force. So if I add these together, what's the total? Let's go ahead and pause and try that. Okay, so to get the total force, what we want is we want to add, so the net force, the total force would be force 1 plus force 2. Now remember, we can't just add up these, so it's not just going to be 200 newtons. That's not how it works. We have to work with the components. And so what we're going to do is we're going to do each of these in terms of its components, Fx and Fy. And then we'll have them on the other side as well. So Fx, that's 2x, and F2y. And so we're going to break this into components. So we'll get the force 1. Well, here, I'm going to define them in their vectors. So F1 would be F1 in the x plus F1 in the y. You know what? I'll go ahead and add the hats in there. So I hat and j hat. And force 2 is going to be force 2 in the x, I hat, plus force 2 in the y, j hat. Now we can redefine everything in terms of trig. So F1 in the x, it's next to. So F1 is going to be F1 cosine theta 1, I hat, plus F1 sine theta 1, j hat. And similarly, F2 is going to be F2 cosine theta 2, I hat, plus F2 sine theta 2, j hat. Now at this point, since we know all these numbers, you can plug them in. So 120 cosine 60, 120 sine 60. I'm going to continue working it algebraically. So the net force is going to be this one plus this one. So what we do is we add up the x and y components. So it's going to be F1 cosine theta 1 plus F2 cosine theta 2. And that's in the x direction, plus F1 sine theta 1 plus F2 sine theta 2, j hat. I'm going to go ahead and calculate all the values. I'm going to put the numbers in there. So substituting our values, we get a net force of 80.75 in the x direction and 181.197 in the y direction. But we want the magnitude. So the magnitude is going to be, so the net force, the magnitude of the net force is going to be this sum, the root of the sum of the squares. So 80.7, say 1 squared, plus 181.197 squared. So we can calculate that really quickly. So we get a magnitude of 198 newtons rather. .358 newtons. That's the magnitude of the net force. And then to get the angle, theta would be inverse tangent of the y over the x. 181.197 divided by 80.7. So theta is equal to 65.99 degrees. It's about 66 degrees. So it's going to be somewhere over in this direction. It makes sense. It's a much bigger force pulling it in this direction, so it's going to kind of end up over here. Anyway, so those are just two basic examples using both components, breaking things up, that sort of thing. There's more examples at the end of your text you may want to go through and, of course, study the quest.